The language of chemistry. Here, we will discuss about chemical symbols, valency, mono, di, tri, and tetravalent elements, radicals, and various compounds, their names and formula. Symbols. A symbol is a short form with one or two letters that represents one atom of a specific element. Rules of writing symbols. Initial letter in capital is the symbol of an element. Example: hydrogen, capital H, oxygen, capital O, carbon, capital C, and nitrogen, capital N. Elements with same initial letter, their symbols are written with two letters. Example: calcium, Ca, chlorine, Cl, copper, Cu. Symbols of elements often used. Metals. Potassium, K, sodium, Na, calcium, Ca, magnesium, Mg, aluminium, Al, zinc, Zn, iron, Fe, lead, Pb, copper, Cu. Nonmetals: hydrogen, H, chlorine, Cl, bromine, Br, iodine, I, oxygen, O, nitrogen, N, sulfur, S, carbon, C, phosphorus, P. Inert gas: helium, He, neon, Ne, argon, Ar. Symbols of first 20 elements of the periodic table. Hydrogen, H, helium, He, lithium, Li, beryllium, Be, boron, B, carbon, C, nitrogen, N, oxygen, O, fluorine, F, neon, Ne, sodium, Na, magnesium, Mg, aluminium, Al, silicon, Si, phosphorus, P, sulfur, S, chlorine, Cl, argon, Ar, potassium, K, calcium, Ca. Valency. Valency is defined the number of hydrogen atoms that can combine with or can displace one atom of the element. Also, valency can be defined as the number of electrons given out or gained or shared by an atom of the element. Mono, di, tri, and tetravalent elements. Monovalent metals. Examples are potassium, sodium, silver. Monovalent nonmetal. Examples are hydrogen, chlorine, bromine, iodine. Divalent metals. Examples are calcium, magnesium, zinc, ferrous, lead, copper. Divalent nonmetal: oxygen, sulfur. Trivalent metal: aluminium, ferric. Trivalent nonmetal: nitrogen, phosphorus. Tetravalent metal: lead. Tetravalent nonmetal: carbon and silicon. Radical. A radical is an atom or group of atoms of different elements that behaves as a single unit and have a positive or negative charge. Let's see some common differences between atom, molecule, and radical. On the basis of charge, an atom is neutral, molecule is neutral, but radical is charged, either positively charged or negatively charged. Let us consider some example. Hydrogen atom is symbolized by H. Hydrogen molecule is H2, but hydrogen radical is H plus. Chlorine atom Cl Chlorine molecule Cl2, chlorine radical Cl-1. Calcium atom Ca, calcium molecule Ca, calcium radical Ca+2. Formula of radical of single atom. Metal and hydrogen form positive radical. Non-metals form negative radical. The number of charge is the valency of the radical. Name and formula of positive radical. Monovalent radicals. Some examples are sodium Na+1, potassium K+1, hydrogen H+1. Divalent radicals. Some examples are calcium Ca+2, magnesium Mg+2, zinc Zn+2, iron 2 Fe+2, lead Pb2+, copper Cu2+. Trivalent radical. Some examples are aluminium Al+3, iron 3 Fe3+. Only one positive radical with group of atoms, that is ammonium radical NH4 whole plus 1. Name and formula of negative radical of single atom. Monovalent radical. Some examples are chlorine Cl-, bromide Br-, iodide I-. Divalent radical. Some examples are oxide O2-, sulfide S2-. Trivalent radical. Some examples are nitride N3-. The name of the negative radical of a single nonmetal has the suffix IDE. Name and formulae of negative radical of group of atoms. Monovalent radical. Some examples are hydroxide OH-1, nitrate NO3-1, nitrite NO2-1, bicarbonate HCO3-1, bisulfate HSO4-1. Divalent radicals. Carbonate CO32-, sulfate SO42-, sulfite SO32-. Trivalent radicals. Example, phosphate PO4 3-. Compounds, their names and formula. The valency of the constituent radicals are exchanged. Written with radical on the right little below. Calcium chloride. The valency of calcium is 2 and the valency of chloride is 1. Thus, after the exchange of the radicals, the formula which we get is CaCl2. Similarly, ammonium sulfate, valency of ammonium is 1 and sulfate is 2. After exchange of radicals, we get NH4 whole twice SO4. Here there is an exercise for you given, where you have to give the formula of the important compounds of some positive radicals. Relative atomic mass and relative molecular mass. Why relative atomic mass? Atoms are very tiny particles. Mass is expressed in atomic mass unit scale. Mass is so small, it is just compared with a standard unit. Relative atomic mass. It is just a number which indicates how many times an atom is heavier than one hydrogen atom, or how many times an atom is heavier than 1/12 of a carbon atom. Atomic mass of hydrogen is 1 AMU. Carbon has atomic mass of 12 AMU. Carbon atom is 12 times heavier than one hydrogen atom. 1/12 of carbon atom is equals to 1 hydrogen atom. Atomic mass of oxygen is 16 AMU. One oxygen atom is 16 times heavier than one hydrogen atom. Relative atomic mass of oxygen is 16. Relative atomic mass of chlorine is 35.5. It means one atom of chlorine is 35.5 times heavier than one hydrogen atom. Relative molecular mass. How many times a molecule is heavier than one hydrogen atom, or how many times a molecule is heavier than 1/12 of carbon atom. Relative molecular mass of water is 18. That means 1 molecule of water is 18 times heavier than 1 hydrogen atom or 1 by 12th carbon atom. How do we calculate molecular mass? Mass of individual atoms are added. Molecular mass of copper sulfate, CuSO4. Cu, atomic mass is 64, sulfur atomic mass is 32 and oxygen atomic mass is 16. 1 copper plus 1 sulfur plus 4 oxygen atoms combine to form CuSO4 molecule. Thus calculating we get 64 plus 32 plus 4 into 16. That is 64 plus 32 plus 64, that is equals to 160. Molecular mass of hydrated salt. Copper sulfate pentahydrate CuSO4.5H2O. That is mass of CuSO4 plus mass of 5 molecules of water. 160 plus 5 into 18, that is equals to 160 plus 90 equals to 250. Percentage composition. Percentage by mass of each element of the compound. Calculation of percentage mass of an element in a compound. Percentage mass of an element in a compound is equals to mass of the element by relative molecular mass of the compound into 100. Percentage composition of calcium nitrate. Relative molecular mass of CaNO3 whole twice is equals to 40 plus 2 into 14 plus 6 into 16, that is 164. Percentage of calcium equals to 40 into 100 upon 164, that is equals to 24.39%. Percent of nitrogen equals to 28 into 100 upon 164, that is 17.07%. Percent of oxygen equals to 96 into 100 upon 164, that is 58.53%. Percentage of water of crystallization. CuSO4.5H2O. Relative molecular mass equals to mass of CuSO4 plus 5H2O equals to 160 plus 90, that is 250. Percent of water of crystallization is mass of water molecules into 100 upon relative molecular mass equals to 90 into 100 upon 250, that is 36%. Chemical equations. In this chapter we'll deal with chemical equation, its definition, its types and balancing of equations. Definition: representation of a chemical reaction with the aid of symbols and formulae of reactants and products is referred as chemical equation. Significance of chemical equation. A chemical equation helps us identify the following: the name of the reactants which undergo the chemical change and the products which are formed, the number of atoms and molecules of reactants and products. It signifies the weight of the reactants and products. If the reactants and products are gases, a chemical equation signifies the volume of the reactants and products. Types of chemical equation: one reactant and 2 or 3 products. Decomposition reaction. Example: 2KClO3 decomposition to 2KCl plus 3O2. 2 PbNO3 whole twice gives 2 PbO plus 4 NO2 plus O2. 2 HgO gives 2 Hg plus O2. 2 reactants and 1 product, referred as combination reaction. Its example are 2Mg plus O2 gives 2 MgO. N2 plus 3H2 gives 2 NH3. CaO plus H2O gives CaOH whole twice. 2 reactants and 2 products. Substitution reaction. Zn plus H2SO4 gives ZnSO4 plus H2. Precipitation reaction. CaCl2 plus Na2CO3 gives 2NaCl plus CaCO3. Neutralization reaction. 2NaOH plus H2SO4 gives Na2SO4 plus 2H2O. 2 reactants and 3 or 4 products. Reaction of metal carbonate and acid. Na2CO3 plus H2SO4 gives Na2SO4 plus CO2 plus H2O. Reaction of metal sulfide and acid. ZnSO3 plus 2HCl gives ZnCl2 plus SO2 plus H2O. Balancing of chemical equations. To understand the above, Let us consider an example. H2S plus SO2 gives S plus H2O. This is an unbalanced chemical equation we have in hand before. Here we can observe that on the left hand side we have 2 atoms of hydrogen, 2 atoms of sulfur and 2 atoms of oxygen, while on the right hand side we have 2 atoms of hydrogen, 1 atom of sulfur and 1 atom of oxygen. Here we can see that sulfur and oxygen atoms on both the sides are not balanced. To balance the oxygen on both the sides, we can put the coefficient 2 before H2O on the right hand side. Thus, we get is 4 hydrogen atom, 1 sulfur atom and 2 oxygen atom on the right hand side, while 2 hydrogen atom, 2 sulfur atom and 2 oxygen atom on the left hand side. Here we can see that our oxygen atom has been balanced on both the sides. Now let us balance 4 atoms of hydrogen, 1 atom of sulfur and 2 atoms of oxygen on right hand side, while 4 atoms of hydrogen, 3 atoms of sulfur and 2 atoms of oxygen on the left hand side. Both hydrogen and oxygen are now balanced on both the sides. Now we are left to balance sulfur on both the sides. Sulfur on left hand side is 3. Thus, to balance this, we can put the coefficient 3 before sulfur on the right hand side. Thus, we get the whole equation as 2H2S plus SO2 gives 3S plus 2H2O. Further, we can see that on the left hand side we have 4 atoms of hydrogen, 3 atoms of sulfur and 2 atoms of oxygen, while on the right hand side we have 4 atoms of hydrogen, 3 atoms of sulfur and 2 atoms of oxygen. Here below are given some of the examples for you to balance the chemical equations.